Hello and welcome. In this unit, we align our readings and explorations on managing information organizations with the Bowman and Deal final chapter on the political frame, that is, the view that organizations operate in large arenas properly viewed as ecosystems. We'll review first briefly what Bowman and Deal think of that for some context, and then look at how that translates to information organizations generally and libraries and digital libraries specifically. Bowman and Deal point out that in addition to organizations being lively arenas for internal politics, they're also active political agencies in larger arena, what J.F. Moore calls ecosystems. By ecosystems, what he means is that organizations depend on their outside environment for resources and therefore must engage with constituents either to satisfy external need or to acquire resources for internal need, much like inhabitants of any ecosystem need to do in order to survive. If you track down Moore's paper in Harvard Business Review, you'll see that he makes a compelling case for the ecosystem analogy. He argues that in, quote, business ecosystems, companies co-evolve capabilities around a new innovation. They work cooperatively and competitively to support new products, satisfy customer needs, and eventually incorporate the next round of innovations, end quote. He gives the example of Apple, which crosses the industries of personal computers, consumer electronics, information and communication, and which has created an ecosystem of suppliers and customers across many market sectors. If you think about it, many large companies operate in or have even created very large ecosystems. I think another great example, perhaps even better than Apple, is Amazon. It is, of course, itself a huge retailer, but it has allowed even its competitors to sell on its platform. It's created a range of products from e-books to home-link smart devices such as the Dot and Echo, and these products integrate with an amazing array of third-party Internet of Things home automation products, everything from home security to lighting to your refrigerators. The rest of the Bowman and Deal chapter is clear and well written, so I don't think I need to summarize more of it for you, and I look forward to reading your discussion of it. If you've taken LIS673 digital curation from me or another course that explores the ecosystem approach by O'Day and Nardi, you'll see some parallels to this unit. Here, I'm using a couple of alternative readings, and our spin more closely parallels the conversation introduced by Bowman and Deal. In the first of the two readings on information ecologies generally, O'Day and Nardi argue that in much the same way corporations and businesses work with a complex of internal and external resources and entities, information organizations also must put together the people, technologies, practices, values, services, and activities to fulfill their missions. Information organizations can be broadly construed and include libraries, of course, but also hospitals, copy shops, and other kinds of organizations. So what are the characteristics of information ecosystems? First, information ecologies may be dissimilar, but they must all have the characteristics of an interrelated system. That is, work must be complementary and related to the whole. Second, there must be diversity, with each part fulfilling a purpose in a complementary way. Third, there must be coevolution. That is, the information ecosystem must co-evolve to grow with change, new ideas, new tools, new activities, and new technologies. Ecosystems adapt or die as a whole integrated complex, not as an isolated collection of unrelated parts. Then there are recognizable keystone species. For a library, clearly the librarian is that, but what other keystone species can you think of that are essential to the essence of the library ecosystem? Locality and habitation are perhaps a little more difficult to describe, But in the sense O'Day and Nardi use it, I believe it refers not only to physical location, but to the sense of a resource's place and purpose in the context of the overall ecosystem structure. So in the case of the computer example given in the reading, it might serve as an OPAC in the library ecosystem or as a payroll machine in a business ecosystem. That's its place. O'Day and Nardi introduced technology as a metaphor and briefly discussed some ways we think about technology as a tool, or as text, or as an assistant, or as a system. They argue for thinking about technology as ecology and suggest that it's useful to think about organizations such as libraries, archives, and museums as information ecologies with a rich set of systems, including people, technologies, and social systems. We looked earlier in the semester at some of the reasons for project and program failure. Here, O'Day and Nardi suggest that technology failure can come about because of failure to consider technology as an ecosystem, that is, an interrelated system of people, services, technology, practices, and values. If too little time is spent on clarifying motivations and ensuring that policies around technology use are consistent with local values, then the ecosystem is not in balance. By focusing on the information ecology metaphor, this naturally leads to thinking about focusing on the key characteristics such as diversity, a sense of locality, the presence of keystone species, and the co-evolution of different elements over time. We're not going to spend a lot of time on infrastructure details in this course, except that you'll probably need to consider the subject on a case-by-case basis in your final group projects. But as Chad points out in the reading, "The library management system is dead, long live the library ecosystem," the library information landscape is becoming increasingly complex as more and more digital projects and services come online. The core functions of the information organization to select, organize, and make information resources discoverable and accessible are vastly complicated when there may be multiple systems that have to be traversed in order to locate all the relevant resources managed by an organization. So, to function as an ecosystem rather than an incoherent collection of disparate tools, information managers rely on a variety of organizing approaches and practices that allow these systems to, in O'Day and Nardi's schema, co-evolve. Metadata, of course, is key, and you study this in more depth in other courses. For purposes of this course, we won't drill into the metadata as much, but we'll have some case studies coming up that you can look at from the management perspective that align with what we've looked at so far, and with our understanding of how organizations manage change. For now, though, I'm guessing most of you are familiar with most of the items on this list, except perhaps the last. So I'll finish off this unit with an introduction to the last two required readings, an introduction to some basic concepts in cyber infrastructure. Libraries have traditionally had no problems managing and storing data for small projects in their traditional institutional repositories. A small data set, for example, might be a few tables or spreadsheets worth of information stored as an attachment to an article, and that would be no more difficult to store than the article itself. Backup would be routine, description would be the same process for the data as the article, and anyone who wanted the data would simply access the article and download the attachment, including the data, with the article. However, today's major research projects often involve data sets that can't be managed as attachments to articles on typical institutional repository systems meant to handle preprints and textile documents. So the kind of infrastructure needed to support the selection, organization, access, and preservation of these types of data sets is basically the kind of infrastructure needed to create and process it to begin with. Cyber infrastructure refers to the large shared online research environments backed up by advanced computing resources hosted in data centers and supported by experts, basically what's beyond the scope of a single institution. The challenge, in theory, is no different than the challenge of interfacing with the institutional repository or e-book lending system. These are systems for which methods of access and interoperability have been developed, along with standard business practices for curation, access, services, policies, and business models. Clearly, libraries need to partner with the data scientists and research experts. These are not in the domain expertise of librarians, or most of them anyway, and we don't teach cluster computing in the MLIS. For example, although that may be a component in our related MS in Information and Data Science degrees, which cross into the computer science domain. So where do librarians fit in, and what are the digital projects librarians might have a role in helping to manage? Well, although it will always be up to the scientists and researchers to maintain the primary domain expertise, librarians can and still do have their canonical role in the selection of appropriate resources for acquisition and preservation, licensing of intellectual property, development and maintenance of appropriate metadata schemas, proper documentation of collections, and scholarly publication. There's a place for data librarians who will need to be able to walk a line between the technological and scientific, who know the discipline of librarianship and information organization, who possess fundamental knowledge of databases, program evaluation, and a host of other skills. I've provided overview articles on cyber infrastructure and libraries that present a good case for the role of libraries and the librarians in the management and preservation of scientific data. Well, that's probably enough for this unit. I look forward to the discussion and your assignment. Thank you for watching.